That is the most interesting thing in geology. Why? Now we all know about Earth has a magnetic field. Magnetic field that controls the different Earth-related phenomena. And in geology particularly, there is a very crucial role that controls the magnetic behavior of magnetically susceptible elements. Magnetically susceptible element कहले कौन? ना iron, cobalt, nickel, etc. These are magnetic susceptible elements. So magnetic susceptible elements are highly affected by the geomagnetism or Earth's magnetism. So the Earth magnetism is very important to control the behavior of magnetically susceptible elements on the Earth crust. We know the innermost region of the Earth is made up of iron and nickel. That is in solid form. And its outer part is almost liquid. The inner part is solid and outer part is liquid. But the composition is almost same. So due to different phase of these magnetically susceptible elements, there is the different behavior of these elements. Thus, the outermost iron nickel liquid core is mainly responsible for the geomagnetism or formation of the Earth's magnetic field. As we know, our Earth is rotating about an axis which is oriented in a north-south direction. And simultaneously, the magnetic behavior of the Earth, which is mainly due to the outer liquid core, that acts as a dipole magnet. You have already studied dipole magnetism. So, this dipole magnetism is responsible for the formation of Earth's magnetic field. If this is oriented north-south direction, the direction of this dipole magnet will be in south-north direction, just the reverse of the Earth's rotation axis. If this is north, this will be south. And the angle between these two axes is almost about 11 degrees. And this is how the Earth's magnetic field is oriented, and this orientation is responsible to protect our Earth from the incoming solar radiation. Here is the sun, and the solar flare or solar star, which is coming in contact to the Earth's magnetic field. And this layer is protecting our Earth from the incoming highly charged particle from the sun. We know our Earth atmosphere is divided into different spheres like troposphere, stratosphere, mesosphere, thermosphere, and exosphere. And this exosphere where the outermost part of the Earth's atmosphere is highly reactive towards this incoming solar radiation or solar particles. And because of this magnetic field of the Earth, this acts as a protective layer, and this magnetism starts from north towards the south. And this is reversible in nature. This is not constant. This is not constant. After 2,50,000 years, probably there is the chance of a magnetic reversal. North pole will go to south, south will go to north. Like this, there is the magnetic reversal. This is called magnetic reversal effect due to the reversing of the pole position. And this reversal effect is mainly responsible factor that help a lot to study the different geodynamic phenomena like continental drift and seafloor spreading. Seafloor spreading. We know in a continental drift there is the movement of continental mass. Continental mass being lighter is subjected to drifting in different directions. That is called what? Continental drift. And another effect is seafloor spreading. What is seafloor spreading? Seafloor spreading means spreading of the sea floor, which starts from the mid-oceanic ridge portion. If we say here is the mid-oceanic ridge, or simply we say MOR, the spreading will start from this point in either side, on either side of the mid-oceanic ridge, and there is addition of new crust on either side of the ridge. If this is normal, then reverse, then normal, then reverse in this pattern. Here is also normal, then reverse, this is normal, this is reverse. Means symmetrically, this pattern will develop symmetrically on either side of the mid-oceanic ridge. So this magnetism or magnetic field of the Earth is mainly responsible for development of this pattern. So how this is? We know the ocean floor that is mainly made up of ferromagnesian mineral, means iron and magnesium, or magnetically susceptible elements are present on the ocean crust. During their formation at the mid-oceanic ridge, when the temperature is about 580 degrees centigrade, below this temperature, these elements are not in a random state, but above this temperature, the elements are highly random stage. So they are oriented in different direction when they are above the 580 degrees centigrade temperature. That is called what? In chemistry we say entropy. Entropy means a state of randomness. But when the temperature falls below 580 degree, there will be aligned. They will start to be aligned in the direction of this magnetic field or Earth's magnetic field. So, if the direction is in this manner, so the magnetically susceptible element will align them in this direction. All will align in this direction. You understand? And this orientational development on either side of the mid-oceanic ridge is mainly responsible for development of magnetic strips. This is called what? Magnetic strips, whose position is not fixed, as there is subsequent pouring of the magma or lava, and that the older plate will be pushed towards the trench region, and the new plate will be added to the older one. So this pattern will develop automatically in a sequential manner. This suggests that the ocean floor is not constant. That means it is dynamic in nature. That means it is spreading time to time, and during this spreading effect, it is recording the magnetic behavior of Earth's magnetic field. That is the geomagnetism. Here, if we say this is the magnetic field, then we can resolve it into two components. This will be what? The horizontal component. This is I. Means this is F, magnetic force. This is horizontal component. So this will be what? I. I means inclination. Inclination. And this is the geographic north, and this is geomagnetic north. So the angle between this is called true north. This is called the this is called geomagnetic north, and this is called the true north. True north means geographic north. Geographic north. This is called the deep or declination. Declination. So inclination or magnetic inclination is the angle between geomagnetic north and the magnetic field, and the declination is the angle between the geographic north and geomagnetic north. Visible geomagnetic north and a true north. The angle will be declination or magnetic declination, and the angle between magnetic field and geomagnetic north or its horizontal projection. This is the magnetic inclination. These two things is very important to know. So what is its implication? Whenever we are searching for any mineral deposit, for example, we are searching for iron deposit, we are searching for chromium deposit. These are magnetically susceptible elements, and their abnormal concentration on the earth crust highly affected to the earth's magnetic field. So that is called magnetic anomaly. This is called magnetic anomaly. Magnetic anomaly means the abnormal concentration of a magnetically susceptible element on the earth crust, which is highly affecting to the earth's magnetic field. If this magnetic is positive, then we will find a curve of this pattern. Means here is the deposition of iron metal. If we are getting this type of pattern, here simply granite rock deposits. You are understanding how the geomagnetism is important to find any mineral deposit in geology during mineral exploration. If we are doing geomagnetic study, then we will find there is a anomalous value found on the earth crust due to abnormal concentration of these elements, iron, chromium, manganese, these elements, and this is highly affecting to the earth magnetic field. So this type of pattern we can get where we will find this type of curve that show there is the abnormal concentration of iron deposit, and if no any deposit, then we can find this type of downward curving pattern. This is called the geomagnetic anomaly. Anomaly means deviation from the standard value. The value of the geomagnetic field should be this amount, and we are not finding that amount, but finding something more or something less. And on Earth's surface, the geomagnetic field is about 25 to 65 microtesla. Earth's magnetic value on Earth's surface. So if we are finding any deviation, that means more from this value, then we are saying that is the abnormal concentration, because we are finding anomalous effect. So this is actually geological implication. Whenever we are searching any mineral deposit, we are doing mineral exploration, and when we are studying the tectonic events like seafloor spreading, continental drift, this phenomenon. So we are finding like this during tectonic study or studying continental drift, we are finding another curve that is called polar wandering curve. Polar wandering curve. What this indicating? This is indicating that the pole is changing its position time to time and producing a curve like a pattern. This is the significance. That is called the polar wandering curve, and this is helping us to find the evidence of continental drift, which is suggested by Alfred Wegener. The continents are not fixed in any position, they are propagating from one position to another position, that is called the continental drift effect. So this is the effect of geomagnetic influence, or whenever we will study the geomagnetic effect on the earth, on the earth crust, we will find the evidence like polar wandering curve, geomagnetic anomaly, and so on. So this is how our earth magnetic field is affecting the distribution of earth crust, particularly sea floor spreading